This video is about confidence intervals. If you haven't done so already, I highly recommend that you watch my video on hypothesis testing and my video on risk before proceeding. Okay, so let's talk about what happens when you do a study. When you do a study, you have a population that you're hoping to make generalizations about. So this is the whole population. And you collect data from a group of people. This is the sample. And from your sample, you calculate a mean. And the mean that you calculate from your sample is a guess. You hope that it is representative of the rest of the greater population that you're trying to generalize about, but you can't be sure unless you give yourself some wiggle room. And the way that you do that is with a confidence interval. Confidence interval makes you more likely to contain the actual population value that you are trying to make a guess at. Okay, so now let's think back to the hypothesis testing video. Remember, in the hypothesis testing video, what we were trying to get at was significance. Was there a statistically significant difference between the two groups? And so the way that we did that was we were comparing two means. And if our p-value, which we calculated from our data, if our p-value was less than alpha, alpha the predetermined cutoff for what is statistically significant, if p was less than alpha, we had reached significance. And if p was greater than alpha, we had not reached statistical significance. So in order to make a more accurate comparison, the thing that we should do is incorporate our wiggle room. We need to include our confidence intervals. What that would look like is same means plus wiggle room. So comparing our two means with a 95% confidence interval is equivalent to using a cutoff of alpha of 0.05. 95% confidence interval, same thing, alpha 0.05. So now, instead of comparing p to alpha, what we're going to check is whether or not our two confidence intervals overlap. So if we have a confidence interval that looks like this and another one that looks like this, we have overlap. And when you're comparing two confidence intervals, overlap means that there is not a statistically significant difference between the two groups. You have overlap, so you have no statistical significance. Overlap is bad. It means that your groups are the same. If instead your confidence intervals are really narrow and you have no overlap, you have reached statistical significance because there's no overlap between the two groups. That means that your groups are different. All right, so how do you get skinny, narrow, little confidence intervals? The way that you do that is with power. Increased power means narrower confidence intervals, means you are more likely to reach statistical significance. And how do you get to higher power? You get a larger sample size, so you include more people in your study. All right, so that is how you interpret a confidence interval when you are comparing two means. You get two confidence intervals and you don't want them to overlap. You are actually more likely to get tested on the interpretation of confidence intervals for odds ratios and relative risk. And remember from my odds ratio and relative risk video that when you have an odds ratio or relative risk greater than 1, that means that you have a positive association between your risk factor and your disease outcome. And if you have an odds ratio or relative risk that is equal to 1, that means that there's no association. And if you have one that is less than 1, that means that there's a negative association. And remember, this is for odds ratio or relative risk. All right, and so for this, what you want to remember is that you do not want your confidence interval to cross 1. So if this is 1 here, this is 0, this is 2, and on and on. Here's the line that we do not want the confidence interval to cross. So if you have a confidence interval that is greater than 1 and it doesn't include 1 at all, then you're in good shape. You still have an association between your risk factor and your outcome. If you have a confidence interval that is less than 1 but still doesn't cross 1, again, you're still in good shape. There still is an association between your risk factor and your outcome. If instead you have a confidence interval that does cross 1, you're in bad shape. There is no association between your risk factor and your outcome. Okay, so to recap, confidence interval is just wiggle room to make sure that your guess includes the true population value. And when you're comparing two means, you do not want your confidence intervals to overlap one another if you're trying to show that your groups are different. And in odds ratio and relative risk, you want to make sure that your confidence interval does not cross over 1 if you're trying to show that there's a relationship between your risk factor and your outcome. And that is confidence intervals.